Hi students, Professor Lamb here. This is I guess PiPad mathematics. This is a problem that I've always kind of wanted to do, so here we are. Here I am doing it, and it's kind of an irrigation problem, if you will. And I can't spell. Let's try that again. An irrigation problem. Okay. And so the irrigation problem is you're a farmer and you have some land, and on that land you have different rows of crops and you need to get water to them. So the question is, how are you going to get water that's sitting over here onto your property when it doesn't fall from the sky? So you have to do some man-made ways of getting water to your crops so that your crops don't wither away. And one way that you can do that is you can dig a ditch, if you will, a trench of sorts, a ditch along one end of your property, and depending on the slope of your land, you'll run water. You'll have some kind of pump, if you will, and you'll run water into your ditch, or it's a tube type thing. The tube has holes in it, and then the water will come spewing out of those holes and then go running down the rows, and you will irrigate your property. Well, another way that you can irrigate your property, where you have some type of property, you have crop rows there, and you can do what's called a pivot. You can build a pivot, and a pivot is going to be, they call a center pivot typically because it pivots around the center, or a center point. And you will build some kind of pump apparatus right in the center of your property, and then you will attach kind of a long string of big sprinkler system, and they will rotate around that center pivot. It will pivot around it, and it will water your property inside of that area. So this gave me the idea, or this real world application of irrigation really connected to a problem that we oftentimes do in a mathematics classroom. So here's the pitch, if you will, that you can give to students. You can find any kind of property, if you will, that cropland. Go to some areas around the country that has a lot of farming, and you can just do a Google search, a Google Maps, and you can zoom in on top of it and you can see property, and you can pose a question such as this. Now what I'm going to do is I'm going to kind of pose this question as it relates, not relates to me, but just is really I grew up in rural Mississippi, and I had a job in rural Mississippi in a town during the summers, in a town called Morgan City. And so I use an app to do this kind of activity here. I use an app called GeoMeasure. The GeoMeasure app. Let me write that down. GeoMeasure. The GeoMeasure app kind of takes Google Earth, Google Maps, and allows you to drop some measurements on top of it. Really useful in a mathematics classroom. So I'll take this again, and so here's Morgan City, Mississippi, on my GeoMeasure app, and so I used to work kind of right around in this area here. I'd drive in from town, and then I'd work in this area, and then we'd get on the road, kind of weave around, and then head out this way to do our summer work out on the fields. And what we would find is, I got to figure out, I have all these wonderful pictures, so bear with me as I'm trying to do this. The GeoMeasure app, the way I'm setting this up, I'm not able to access it right now through my iPad, so I don't have internet on the iPad, so I'm not able to kind of utilize it and show you how it works in real time, but you can get the idea. So here is, you drive down the property, or drive down the road and you find a piece of property and you say, okay, here's a piece of property and I want to irrigate it. So what am I going to do? And what we're going to choose to do is get a center pivot. We want to install a center pivot, and we're going to need to answer a few questions about that. I found as close as I could to a square piece of property, and we'll notice that when you do the GeoMeasure, you can draw a line, you can create a distance on the GeoMeasure app, and then it will tell you how far it is in feet. And so what we'll do is we'll go, that's 1,290 feet. We'll round to the nearest whole foot. And so we have a square piece of property, and we're going to call it square for now. And when you're doing this with students, well, it doesn't look as square, and say, well, we're going to call it as square as possible right now for this problem, and then later on we're going to do the not so square properties and figure out how to solve for those. So we start here, we have a square piece of property, and it's 1,290 feet are the lengths of its sides, and we want to irrigate it. So we need to now try to learn a little bit about the center pivot. And you can do activities with the students to say, all right, well, what we're going to do is we're going to do some research with it maybe. We're going to Google it. We can, or you can take what I did was on my GeoMeasure app, I went a little bit farther down the road and I found a piece of property that had a center pivot on it. If you can notice, this piece of property right in here has been irrigated using a center pivot. Here it is the pump right in here, right in the center of the property, and then the pivot is a long line of different attachments, long sprinkler system, and it is rotated around and made this circular area has been irrigated. And what you'll notice is it has these kind of little lines that go all the way in nice circles around the property. And so we should ask, well, what is that? What does that mean, or what does that have to do with what we're trying to accomplish? And so what we notice is that when we zoom in, and of course if I'm on the app I would just zoom in on the app right now, so I'm just showing you screenshots of what kind of what I came up with or what I found. And so when you zoom in, you'll notice there's your pump, and the first attachment is kind of from right here to here, and it has a set of wheels right in the bottom, and those wheels is this mark here. And of course the downfall of a center pivot is the fact that it's going to run over your crops, and so you're going to have this area that I've just outlined in white that's not going to have any crops that are going to grow on it because the wheels will trample it throughout. But you have this, and then you have another section that they attach. I'll do it in a different color. So here's a second section, and then what you'll have is you'll have a third section, and you can zoom out and you can find out, from our previous image, kind of how many sections there are. But with this, what I want to do is I want to illustrate to students, all right, well, you're going to put a center pivot in, so you're going to put your pump somewhere in the middle of your property, okay? And then you're going to need to find out how many of these sections you're going to need to purchase. And so we're going to go in and we're going to figure that out by finding out how far, or what is the distance of each one of those sections. So here we are. We have a nice little section here, and with GeoMeasure it tells you the distance of that section there. So it was 118 feet. So 118 feet. So our question is going to be how much we need to build a pivot. We need to put in a pivot. So we go back to our original property that we are trying to build a pivot on. Let me move some of these things around so you can kind of remember where we were. And Give me a sec. It's this one right here. We're going to zoom in a bit. Here is our piece of property. Okay? And remember, it was a square piece of property, is 1,290 feet, and we're going to put a center pivot in the middle of it, and we need to figure out how far we can build our pivot on that property using the sections. So that's the first problem that you pose to students. It says, well, how long is our sprinkler going to be? How long is our pivot going to be? And they go to calculate that, and we as very smart, bright math teachers, we can quickly see that, well, if the length is 1,290 feet and each one of those sections is 118 feet, and we're only going half of that distance, we would first take 1,290 feet and we would divide that by 2, and then we would divide that whole thing by 118. So I have a nice little calculator to help us out here. So we have our 1,290 feet. We're going to divide that by 2, and that's going to give us 645 feet. And then we're going to divide that by 118, and that's going to give us 5.466, if you will. So this is another problem solving kind of activity for students to say that it was 5.466. Does that mean that we can buy part of a pivot? And we stipulate that. No, you can only buy a whole length, which is 118 feet. So we can get 5 of them, and then there's a part left over. So 5 of them is as far as we can go. Alright, so 5 is how many we need to purchase. So we'll go back to our picture, and here we are on our picture, and therefore we're going to be able to get 5 going this way. Well, how far or how long is 5? Well, that's the other problem, is to see that what is that total length. And the way we do that is we're going to take our 118, and we're going to multiply that times 5. So 118 times 5, we can go to our trusted calculator to help speed up the calculations. 118 times 5 gives us 590 feet. So therefore, this is going to be 590 feet. Okay? And what is 590 feet? 590 feet is the length of our pivot that we're going to be able to build. So we have on this app that I'm using right now is called Explain Everything. What I can do is I can kind of create a circular area, if you will, and I can move that around, and I notice that is not going to be it's not going to reach all the way to the edge. And how do we know that? Well, we know that because when we divided, we found 5.466 was the length of the total pivot that we needed, but we can only buy sections that are 118 feet long, and therefore we can only get 5 of them, and we'll have a little bit of extra left over, and that's this spot right in here, that's this spot right in here, and this spot. Notice it doesn't go all the way to the edge of the property. So what we have is we're going to have a center pivot here. We're going to be able to stretch it 590 feet. Let me undo that. I didn't write very well. 590 feet. Okay? And we're going to be able to irrigate that property that's in yellow. So you can pose a number of questions to your students right now. You can say, all right, well, how much of the land is not going to be irrigated? How much is irrigated? How could we fix the property so that it irrigates all of it? These are questions, real world questions, that you can ask your students. Well, so let's start off with the one that says, how much is not irrigated? So the question is, how much is not irrigated? Okay, so we go back to our picture, and what is not irrigated is going to be, let me put it in white, is going to be this area right in here. All the part of the property that's not covered by your center pivot. How do you figure that out? Well, this is the problem solving, this is the task that you ask students, and the students should realize that you need to first find out what is the area of the overall square property and then subtract the area of the circular property. And that's kind of where all of this began for me in doing this problem, is that you so often in our classes, in our mathematics education classes, hold on, you'll have something like, here's a square piece of property, and then inside of that you have a circular piece of property. They'll give a picture. They won't even say property, right? What they'll do is they'll say, alright, they'll give you some dimensions of these things, and let's just, for the sake of joy, that's a square and that's a circle that is inscribed in it. And what we have is how much is not shaded, or how, the circle is shaded, how much is not shaded. Well, the irrigation problem actually allows us to do that in a more realistic terminology. Here's a piece of property. Here is a pivot, center pivot, a length that you have. You have to calculate the length and then figure out what is not irrigated. Well, let's do that calculation. We got to first find the area of the overall property. The overall property is 1,290 feet, right? So we square it, and that gives us the area of the property. Let's do that. 1,290. We can square it, so it's 1,664,100. So we go back to our property here, equals 1,664,100 feet squared. Okay, and we need to subtract, so subtract circle, and the area of the circle, you got to remember it's pi times r squared. Okay, and we know the radius of the circle. Move over here, the radius was 590 feet. So what we're going to have is, we're going to have pi times 590 feet squared. And you can use 3.14, but because we're working with such large numbers, we want to get students to start using this, where calculators are really good to get more exact answers, to where you allow students to go off to a number of significant digits so that the error is not magnified by the multiplication of large numbers. And we have our 590. We're going to square it, and then we're going to multiply that times pi. So times pi equals, we got 1,093,588. We'll go ahead and round it to the nearest whole square foot. Alright, so here we are, and that's going to be, we'll write that 1,093,588. And the question asks, what is not irrigated? So you take the area of the property, and then you subtract the area of the circle. And we will do that on our wonderful calculator here because of our speed at which it will do it. 1,664,100 minus, or subtract, 1,093,588, and that's going to equal 570,502 square feet. So the answer is that you would ask questions or students is that this property right here that is not irrigated equals 570,512 square feet. And so a farmer's going to say, well, man, that's 500,000 square feet. That is a lot of property not being irrigated by my center pivot. I need to fix that, or I need something that helps me fix it. And so what they do is they sell the center pivot like this, and most of the property is covered by it. All right, and but what happens is they'll put right at the end of our little pivot, they'll put a sprinkler system that kind of goes back and forth, and it covers that property that's not irrigated. Of course, this isn't the most ideal. Not all of the property is being irrigated or watered as much as it needs to be watered, but it does serve a purpose. It does allow for getting most of that property watered. But you know, all in all, the point of this whole problem is to get you to see that you can start off with, we have a piece of property and we need to irrigate it. We need to get the water to the property when the clouds are not producing rain. And so how do you do it? A couple different ways, and here's one. With that center pivot, it creates circles on properties, and that allows you to pose a problem such as when you have a circle inside of a square, how much is not covered by that circle. And this is a real world type problem for it. So here's the irrigation problem, kind of with some crazy big numbers, if you will, but it is more realistic than some that you just get out of a book. So thanks. Again, I'm Professor Lamb. It's PiPad Mathematics.